What if I told you that the biggest solar storm in 20 years has just hit Earth? We were fortunate this time, but astronomers remain vigilant. The most violent solar cycle in a long time is ongoing, with a massive sunspot emerging, reminiscent of one that caused a catastrophe in the USA 200 years ago. If this spot continues to grow, we could face serious challenges ahead. Currently, astronomers predict two possible outcomes: either breathtaking auroras painting the skies or potential chaos, with communications and power grids paralyzed within minutes. Elon Musk recently voiced his concerns. On May 11, 2024, the SpaceX CEO shared a worrying graphic illustrating the strain the recent solar storm put on his Starlink satellites. These modern marvels faced unprecedented pressure, pushing their protective mechanisms to the limit. A more severe storm could potentially overwhelm or even destroy these satellites, a nightmare scenario. Imagine not only regional internet and mobile networks failing, but also a space littered with dysfunctional satellites. Solar storms are increasingly recognized as a significant threat of the 21st century. Experts have long warned of a looming superstorm that could challenge our entire civilization. These storms involve particle streams from the sun interacting with Earth's magnetic field, creating the mesmerizing auroras visible near the poles. What many don't realize is that these auroras signify electromagnetic particles trapped and guided by Earth's magnetic field, showcasing nature's light show. The recent solar storm, the strongest in 2 decades, extended auroras far beyond their typical range, offering spectacular displays of green, purple, blue, orange, and sometimes red hues across both hemispheres. However, the concern persists as experts predict continued intense solar activity for the foreseeable future. Whether these storms continue to dazzle us with auroras or pose imminent threats remains to be seen. The speed at which solar flares impact Earth is startling. Within minutes of a solar eruption, particles can reach our planet, propelled by sunspots or coronal mass ejections (CMEs). Sunspots, darker regions on the sun's surface due to intense magnetic activity, can trigger these eruptions, releasing vast amounts of energy and particles into space almost instantaneously. One notable group, R3D 664, recently captured attention by producing 75 M-class and 10 X-class flares in just a week. M-class flares are medium-sized, while X-class flares are among the strongest, with one reaching X45 intensity. These events not only shower Earth with particles, but also have the potential to cause massive CMEs, further complicating our technological landscape. R3D 664, visible even with solar eclipse glasses due to its size, has been a focal point of recent solar disturbances, affecting satellite operations and reminding us of the sun's unpredictable power. Currently, we're in the midst of a solar cycle lasting approximately 11 years, with solar activity peaking. This cycle is marked by extreme and sometimes unpredictable fluctuations. During the solar maximum, we anticipate the most powerful X-class flares and the potential for the feared superstorm that experts have warned about. What concerns scientists now is that this current maximum has arrived earlier than expected, suggesting unusual behavior in the sun. Recent observations of R3D 664 even hint at a possible reversal in the sun's magnetic fields, which could lead to more frequent and intense geomagnetic storms. The last major solar storms, such as the Halloween storms of 2003, reached G5 intensity, causing global disruptions to power supplies and satellite communications. Auroras were visible in unexpected regions like Florida and Mexico. Forecasts suggest that R3D 664 could generate storms of similar intensity in the coming weeks. While currently pointing away from Earth, R3D 664 will soon rotate back towards us, potentially triggering another season of intense geomagnetic disturbances. Historically, the Carrington event of 1859 stands out as the most powerful documented solar storm. Named after British astronomer Richard Carrington, this event was triggered by an enormous sunspot region that led to intense geomagnetic storm activity. Within hours of the solar flare, Earth was bombarded by a coronal mass ejection (CME), producing spectacular auroras visible across Europe, North America, and even as far as Cuba and Hawaii. In the USA, the Carrington event caused significant disruptions to telegraph infrastructure. Sparks flew from wires, causing fires and widespread damage. Imagine looking up at the sky in the morning and seeing it ablaze, a sight witnessed by many during this event. The technological impact of 1859 was severe, but today's consequences would be catastrophic. Our modern civilization, reliant on satellites, power grids, GPS, and communication networks, would face unprecedented disruption. The economic damage alone could reach trillions of dollars. Solar storms, including solar flares and CMS, are normal occurrences driven by intense magnetic activity on the sun's surface. While they pose no direct threat to humans or nature, our technology is vulnerable. Flares are sudden bursts of energy, visible as bright eruptions on the sun, releasing light and high-energy particles into space. CMS, in contrast, eject large clouds of magnetized plasma, typically reaching Earth within hours to days. The Carrington event vividly illustrates the dual nature of these phenomena: spectacular auroras, but also potential technological havoc. It's a stark reminder of the sun's power and our reliance on technology in an interconnected world. The Carrington event of 1859 was truly exceptional, yet we must acknowledge the potential for such an unusual particle stream to impact Earth again at any time, an unsettling prospect. Particle streams, composed of protons, electrons, and heavy ions, though potentially hazardous, serve essential roles. They contribute to space weather, transport energy through space, and help shape our climate. Moreover, the continuous flow of charged particles from the sun's outer atmosphere forms the heliosphere, shielding our solar system from cosmic rays. Without these particles, life on Earth would likely not be possible due to exposure to intense cosmic radiation. To harness and safeguard against these ostensibly benign yet powerful natural phenomena, we must continually advance our technologies. Did you know that modern satellites are engineered to withstand space storms and flares? They are designed to remain resilient against strong electromagnetic fluctuations. However, this level of protection applies only to a minority of satellites and power grids. Many networks and devices remain vulnerable and outdated, susceptible to failure during severe storms. Governments worldwide are increasingly prioritizing protection against solar threats. Electricity companies are developing new technologies to fortify their grids, substation, and power plants. For instance, the Geomagnetic storm of 1989 severely disrupted Canada's power supply for an entire day, highlighting the vulnerability of our infrastructure. Satellites in Earth's orbit, including the International Space Station and its supply spacecraft, are most exposed to high-energy particles from the sun. These particles can damage electronic components, potentially leading to critical malfunctions in space. Even minor failures can escalate into life-threatening situations, a concern shared by figures like Elon Musk and NASA.